Testing. Test. Hello. Hello. I think I'm alive. All right. I hope I'm audible. Okay. So here's some formulas. So I'm seeing some areas, volumes, so on some distance rate formula, some conversion formula. Basically, I'm providing formulas. Extra page. Okay. Yeah. So practice exam 4. I have 0 people here at the moment, but I hope you can hear me. Maybe I'll, check in myself somehow here. Hello? Okay, I'm hearing something. All right, that's working. So practice exam 4. See what the first one is. Okay. The equator of the Earth is about 25,000 miles long. So the equator, that's that midline that goes all the way around. So assuming that the equator is a circle, find the radius and diameter of Earth. Use 3.14 for pi. So unless otherwise stated, I'll be using pi for pi, but this says use 3.14. Round your answers to 1 decimal place. Okay. So we have, circumference then. So we have like a circle here. And we know this is the 25,000 miles to go all the way around that. So this is my equator just drawn on this page. And we're supposed to find the radius. And once we have radius, we can just double it. So it's true that d, the diameter, is 2 times r. So this would be r, something like that, d. Okay, so radius and diameter. So looking at like the formula sheet, assuming I'm stuck maybe. So I have these, and this right here, this one is going to be the winner so far. So C equals 2 pi r. So this is C. So we have 25,000 equals 2 pi times r from that formula. Okay, I'm supposed to use 3.14 for pi. So I can go ahead and divide by 2 pi. And what I'll be typing in is r equals about 25,000 divided by 2 times 3.14. Sorry. I forget my camera skills already. So yeah, I'll type that in. This will be roughly that number. All right, so 2 decimal places. Sorry, 1 decimal place. So this is about equal to 3,980.9. And this would be miles. It didn't say to include the unit, but this would be right there. And then diameter would be roughly equal 2 times that. Looks like someone's here. Is that true? I don't know if you're able to use the chat. I think I have it activated. Okay, so 8, that would also be miles if that were important. Cool. Radius, diameter, 1 decimal place. All right, that was that. So to estimate the area of each trapezoidal region, it says use centimeters as your unit of measure. Okay. And for full credit, include appropriate units with your answer. So this one does want units. So I would just literally do some direct measurement. So we'll get, maybe kind of the concept is, you know, I'll split this up as like a rectangle and a triangle for this first one. And I'll just make the appropriate measurements, right, based on the formula sheet up front. There's area of a triangle here, area of a rectangle up here. So now we're kind of looking here and here. All right. So treating this as a rectangle and this is a triangle. So using centimeters. So I'm on the centimeter side, and I'll make this measurement. We'll make all these appropriate. I'm just doing my best. It's never exact. I'm calling that about 4.3. Looks like this one's going up slightly. You know, so I could actually get a little bit more specific. Looks like it is kind of going up slightly, you know, now that I get this straight edge on it. Could get that specific. Let's see, that would change this one. So that would be a rectangle now just here. And this would be like a second thin, sideways, triangle along with this other wider triangle. Maybe I'll do it this way. So if that is actually my rectangle, see how that's actually closer to 3.9 now. Do it like that. So that must mean this sliver is 0.4. All right, so we have this vertical then as the rectangle. So I'm going up the line that I drew, and that is roughly 4.3, I'll say. So that would be the same as this over here. So I have this, 4.3. I have this sliver. I need this over here. So this is about 2.1. So area. So I'll have 1/2 the base of this one, 2.1, times the height, just 4.3, plus the area of this rectangle, which is 4.3. parentheses, times 3.9 plus the area of this thin triangle here, 1/2 times 0.4, 4.3. I forget how I did it in the posted key. It may have been different than what I'm doing here. I may have treated it just like a rectangle, and I literally forget. But try not to worry about duplicating exactly what one does on a key, and focus more on, did you respond to the question appropriately? So I'm doing a bunch of typing over here, sorry. So that was just typing in what's above. I'm using 0.5 instead of 1/2. It spits out this. I'll press this button here. So here's an okay decimal. Include units. Didn't say to do any further rounding, so I'll just write this. So this would be 22.145. And this is square centimeters. Area. Okay, here's our other region. So we're supposed to estimate the area, use centimeters. For full credit, include units. Sorry for the wiggling of the video. All right, here's the next one then. For kind of, so the video is not too long, I'll just treat this as a single, like, rectangle next to this rectangle. So we have, rectangle, and then we have triangle. That's one of many things you could do. So again, this is not like, oh, I needed to do exactly what he did. No, we just need to find the area, and there's a bunch of different ways to split this region up. But this is just what's jumping out to me. So we have, I would say 9, fine. Close enough. I need this side, right? So I kind of need to get a pretty good estimated line for like where this thing is sliced. So what I'm trying to do is actually get this hash line lined up with the actual, so I know that's pretty good perpendicular. So that's a good rough estimate. Now we'll say, I'd say 4.5 is fine. I'm going with the same thing over here as over there. Seems okay, right? We have like the height of the triangle, which is this. I'm calling this the base of the triangle. And then we have length times width of the rectangle. So area, we have 9 times 1.5 plus 1/2 times 4.5 times 9. This button again, so 33.75. But either way, if you wanted to leave it, so I'm pressing S to D, standard to decimal. if you wanted to write it as 135/4, that's great. Okay. So here's number 3. There are 2 bars of new clay, each shaped like a right rectangular prism. Let's get that back page out of the way. Dimensions 1/2, 2, and 8. One of the clay bars is rolled into a sphere, whereas the other retains its original shape. Are the 2 final shapes congruent? Okay. No. So, no. 2 objects, maybe I'll say. Need to be the same shape and size to be congruent. So it said that one's basically a box, you know, like a solid box, but a right rectangular prism, like a brick. And then the other one is a sphere, so a ball type thing. So definitely not. How do the volumes of the bar and the sphere compare? Well, it said there are 2 bars of new clay, each shaped like a right rectangular prism with dimensions. One of the clay bars is rolled into a sphere. Okay, so it says each, originally they come out like a brick with these dimensions, but one of them was rolled into a sphere. So the 2 final shapes are not congruent. So they're not the same shape. They're changed. Right? But the volumes of the 2 things is not going to change. They're still the same amount of stuff. I'm assuming the brick was just formed into a sphere with no like removal. So they're the same. So assuming no clay was removed. All right, so what is the radius of the sphere? Show your work. Round your answer to 2 decimal places. So formulas. So volume of a sphere. For sure. And where is the other one I'm looking for? Did it not make it onto here? Okay, no, it's here. Sorry. So for this current problem 3, part C, we're looking here and here. Okay. So the volume of the original shape. Okay, so the volume of the original shape, we had this information. So the volume of the original shape must be length times width times height. Basically the 3 dimensions. This is not like an area formula. You know, this is volume. So one of the, you basically like this type of situation where you have 8, this is the half along this side, and this is the 2 along this side. So this is the kind of bar of clay that is maybe coming out of the package. So this has a volume, and it's equal to this volume. Okay, so that's 8. And that would be, it looks like inches are being used, this kind of double hash marker, what have you. So this would be cubic inches. But then this thing gets kind of flattened. Right, to some extent. It's kind of, but then it gets changed into some sort of approximation of a sphere. Okay. So the question is about, what is this? You know, if you start with this much stuff. So it must be that that volume is equal to the volume of the sphere. That's what we said in part B. So we could solve this for R. So I'll multiply both sides by 3. We have 24 is 4 pi r cubed. I can divide both sides by 4 pi. So 24 divided by 4 pi is r cubed. And now I'm trying to undo something cubed. So I would take the cube root of 24 over 4 pi. And then it said 2 decimal places. So in here, cube root is going to be kind of behind the square root. So you'll say shift, let's get rid of this actually. So shift, cube root, and then fraction, 24, 4 pi, and then we'll round. So 1.24. Right, it didn't say to include units, so I'm just not boxing them. Okay. Next. All right, here's our next one. It says draw and find the length of each diagonal of each face of the right rectangular prism and the inside diagonal. How long are the other inside diagonals? Find the length. Oh, this is the hint now. So find the length of the diagonal of the base first. Yeah, okay, we could do that. So it says draw and find the length of each diagonal of each face. So yeah, if we have this box, basically, there's 3 pairs of unique faces, if that makes sense. Like the front is going to be identical to the back. The right is going to be identical to the left. Top is going to be identical to the bottom. So that's 3 pairs of identical faces. So we only have to draw 3 pictures for those. So let's do that. So let's see, how do we, so I'll say like front slash back. We'll start there. Okay. So for the front, I'm calling, of course, this kind of thing that's facing out of the page, the front. So I have a rectangle. That is 9 by 6, right? It's this vertical, so that's not 6. So it says draw and find the length of each diagonal. So there's kind of this, I guess we're fine here, so this diagonal that we're supposed to find for this. Right, so this is a Pythagorean theorem problem, basically. We have that 6 squared plus 9 squared should be equal to like that first diagonal squared. So the square root of 36 plus 81 is equal to C1. I've taken the square root of both sides here. So square root of 36 plus 81. We have this. Are there people here? I'm seeing that there's 3 whole people here. Is that true? Is the chat just going wild? Meaning, is it possible to chat? Yeah. Kevin is here. That's so funny. Kevin, did you just see that my YouTube channel popped up, or did I accidentally email this to the wrong class? Let me see. I think I emailed this to the appropriate class. But let me make sure. That would be kind of funny at this stage. So I'm going through the practice exam for Math 210B. So I'm hoping I sent out the link to Math 210B students. Let me make sure. Yeah, I did. Okay. So I think Kevin's just on top of it and subscribed to my YouTube channel. That must be the case. Cool. All right, back to the business at hand then. So yeah, Kevin's doing some extra learning here. Never a problem with that. So I have this number. And I'm looking at the thing. It says, you know, how long? I'm not seeing anything about rounding. So I would just say, okay, it's this. I have 3 root 13. So that's the first one. So draw and find the length of each diagonal, each face of the right rectangular prism. So that's front and back. That's the length of this diagonal. And then let's say left slash right. So these are smaller. We have like this size. But still, I guess they're not quite that small now that I look at it, but yeah, whatever. So C2. So 8 squared plus 6 squared would be C2 squared. The square root of 64 plus 36 is C2. And then just calculator again. But I can kind of see what this one is. 64 plus 36. Yep. So that would be 10. Technically it's centimeters. But I'd be okay if you just box the number. And then bottom and top. So this thing and this thing. So we have the rectangle. And we'd have 9 across here, and it's 8 across there. So we're looking for C3. So 8 squared plus 9 squared equals C3 squared. You know, the Pythagorean theorem just requires that this hypotenuse is what it adds up to and equals, right? It needs to be that things are adding to the longest side. So make sure to get that part in order, and then we take the square root. So 64 plus 81 is equal to C3. I'm seeing this, so I'll just go ahead and box that. So those would be the, as it was said, the face, so diagonals of each face. But then it also said the inside diagonal, so kind of this upper left vertex to a cross and inside bottom right vertex. Sorry, this situation, kind of upper left, inside bottom right. So we'll find that one as well. So there's kind of this, if you imagine it, this right triangle going kind of across like that. So that one. Okay, so we have that is the hypotenuse of that triangle. So I'll say kind of inside. So yeah, I see the hint now, right? Because it says find the length of the diagonal of the base first. So that's this leg. We already know this leg is 6. So the diagonal of our bottom is the length of the leg of this particular right triangle here, right? The diagonal of this base is actually one of the legs of this triangle associated with the inner diagonal. Okay, so that's kind of interesting. We'll have then this triangle we have figured out from this part right here that this thing is the root 145, and we have that this thing is that 6. So this triangle is kind of going, it's that one going kind of into the page. All right. So this, let's see, what did I call this in the key? B1. I don't know, D, I'll call it here. So we have 6 squared plus root 145 squared is equal to d squared. So we have the square root of 36 plus 145. These things are just eliminating. So square root 36 plus 145. I'll just leave it this way, root 181. All right, yeah. If you have questions, I can see the chat here. So if you have any particular things, let me know. I'll go to number 5. Okay, yeah, these semicircles. So it's saying find the areas of the semicircular regions drawn on the sides of the right triangle at right with, well, below, with A equals 6, B equals 8. How are the areas of the 3 regions related? That's the question. So I'm supposed to find the areas, the semicircular regions, and then really supposed to relate them. Please show your work. Yeah, okay. So area of a circle, this is coming up for sure. So back here, we're now looking here. That one right there, pi r squared. So yeah, for, let's see, I'll find like area of what I'll call semicircle A, right? It's attached to this side A. We were told that the lengths of A and B are 6 and 8. So we have this 6 and 8 happening. Okay. So it's likely we're going to need C. So 6 squared plus 8 squared will be equal to C squared. And this is literally just the straight line length. Just ignore the circles for now. So we'll have 36 plus 64. Again, we saw that. Square root of that is C. So we have a 10. Okay, so we have this as well. That's just the length. I'm not saying that's the area or anything. That's actually the diameter of that circle, right? That semicircle. So each of these numbers we just found are diameters of the associated semicircle. So we'll cut them in half and use those as radii in the formula. Right, we have this formula again, and that's radius. So we're kind of told diameters here. So area of kind of circle A, maybe I'll call it, right? It will be pi times 6 over 2. I'll just show that work, but I could do that separately. Squared, but then I cut that in half as well, right? Because there's only half of the circle. So this is the same as pi times 3 squared and then all over 2. So I'd be able to say 9/2 pi. This would be square centimeters for that part. So cutting 6 in half, because 6 is actually the diameter and the area depends on the radius, but then there's only half of that circle there. And our formula is for the entire circle. So we're cutting the formula circle in half. So this is cutting the diameter into the radius, and this is cutting the full circle into a half circle. So the area of the B associated circle, semicircle, so pi times 8 over 2 squared, just showing our halving, and then another halving. So we have pi times 4 squared over 2. This is pi times 16 over 2. This is 8 pi square centimeters. So this is for finding. And then there's eventually this how are they related part. But we're working on this find part at the moment. And then C. So we have pi times 10 over 2 squared all over 2. So this is pi times 5 squared all over 2. This is 25 over 2 pi. So I'll go ahead and kind of box those since it was asked for. But then there's also the comparison. So like if I add them up, so if I kind of try to treat them as they are kind of related to the Pythagorean theorem, if I go ahead and just assume that, then we can see that 9 halves pi plus 8 pi. If you type that into our calculator, this literally is 25 halves pi. So this is like our a squared plus b squared equals c squared. So they are related by the Pythagorean theorem. All right. Let's get to number 6. Number 6. It says triples of whole numbers such as the earlier 3, 4, 5, 5, 12, 13 are called Pythagorean triples because they are positive integers that fit an a squared plus b squared equals c squared relationship. Which of the following are Pythagorean triples? So we're just checking here. Kind of fairly basic problem. So we're just seeing, is it true that 5 squared plus 6 squared is equal to 7 squared? If we have a shot at it, the biggest number needs to go on the side that's alone. Okay, if we're adding and squaring, then for sure those squared sums need to add up to the largest. So now I'm just seeing if this is true. So 5 squared plus 6 squared, that is not equal to 7 squared, which I know to be 49. So 61 is not equal to 49. So this question, I would just say no. Maybe this is good. Right? You could do this. I think that would get your point across. So 6 squared plus 8 squared, are you equal to, maybe I'm like checking, that's a good thing to note. Maybe I don't want to claim it's equal if it's not. So is this the case? Well, 36 plus 64, we've seen this. All right, and so forth. Yeah. Okay. If x, y, and z give a Pythagorean triple, will x multiplied by k, will y multiplied by k, will z multiplied by k also? So we have this to check. All right, if this is true, then yeah. So we square both items. So we have like a k squared times x squared plus a k squared times a y squared equals a k squared times a z squared. Right, we can essentially factor out a k squared. And yeah, the k squareds can cancel just fine. So we have x squared plus y squared equals z squared, which we know is already true because x, y, and z give a Pythagorean triple. So yes, maybe I'll circle it. It says use the idea in part D to generate one more Pythagorean triple. So it's saying like if I just pick any number and multiply it by a known Pythagorean triple, then I have another one. So if I have, let's say k is 2, well, that's actually how I got this one, right? B and C. C is double B. Like what if I had used 3, right, on B instead of 2? So if x equals 6, y equals 8, and z equals 10, which you don't need to start with, but I can use k equals 3, which also you don't need to use. But this is just one way. So I can say x times that k is 18. We have k times that y is 24. Then we have k times our z is 30. This would be it. Another one. I wrote some other one on the key. All right. Number 7. Oh, Kevin, I just saw your question. But yeah, you can turn that in whenever. Tomorrow's fine. Or Monday. Find the perimeter and area for each triangle described. Give an exact length as well as an approximation if appropriate. A right triangle with these legs. So I'm supposed to get the total perimeter. So we have like 1.6, 6.3, not to scale. Right, this would be my C value. So it'd be that 6.3. Right, I put those there because those are legs. So this is called the hypotenuse, these are called the legs. So plus 1.6 squared is equal equal to c squared. So square root of 6.3 squared plus 1.6 squared is equal to c. And then we'll just add them all up. Right? Perimeter means what is the length of that, plus that, the distance all the way around. So 13 halves for C. So for perimeter, it'll be 13 halves plus 6.3 plus 1.6. So either number is fine. They're both exact. It doesn't really make sense to round. This would be meters, if that were important. So find the perimeter, give exact length as well as approximation, if appropriate. So I'm calling all that good. A right triangle with one leg 4 and a hypotenuse 8.5. So here we have like this and then this. So I would call this maybe like B, and I would have this as my setup. 16 plus b squared is equal to 8.5 squared. Okay, so subtract over this. So b squared is 72.25 minus 16. Take a square root of that. So b is the square root of 72.25 minus 16. Let's see what that is. It's this. 7.5. So perimeter is going to be 7.5 plus 4 plus 8.5. No rounding. That was confusing. So yeah, feel free to like come up and ask about something like this. That would have been a little strange. Okay, number 8. Okay. Is this last one? All right. Trying to get it to focus. There we are. Okay, an outstanding runner can run 100 meters in 10 seconds. What is the runner's speed in meters per second? So speed is always distance per time. So it could be in a lot of different units, but we have our distance as meters in this case, and time is in seconds. So speed in meters per second is 100 meters divided by 10 seconds, and that gives us 10 meters per second. Not a whole lot to be done there. What is the runner's speed in kilometers per hour? All right, so if you don't have that, we have this thing here, right? Because we have meters per second, we want kilometers per hour. So we're looking down here. 10 meters per second. I'll convert this. So we have 1,000 meters for every 1 kilometer. All right, so that'll take care of these. Now I'm in kilometers per second. So if I want to show this other work, there are 60 seconds for every 1 minute. And then there are 60 minutes for every 1 hour, each hour. Okay, and then if we carry all that out, sorry, the kilometers is what we want everything else. So kilometers per hour. So notice like everything else actually cancels. Right? And yeah, kilometers per hour. So I'm just carrying out this whole set of multiply. So 10 times like 1 over 1,000 times 60 times 60. 36. That is pretty fast. Okay. Wow. All right. That's that. Are there any questions out there? See, there's one person. So, yeah, thank you. Have a good rest of your day, everybody. Bye-bye.